So in class today, we were trying to set up this barge in the tugboat picture. We had these two tugboats trying to pull this barge. And we saw that because this blue vector here had more force, it was going to pull the barge closer in its direction, so just south of the x-axis. But what we were starting to look at are the 4 steps that it takes to actually solve this picture, or to solve for this green resultant vector. The first and second steps is you have to find the horizontal and the vertical component of the blue vector and the red vector. So that's what we're going to do right now. So step 1, find the horizontal component and the vertical component for this vector right here. So if I'm solving for this, I'm going to re-sketch this. Here's my blue vector, 18,000 pounds, at a degree of negative 10 degrees from standard position. I'm using negative 10 because it's going down in the negative direction. You could also use a positive 350 degrees. Well, our formulas to find the horizontal and vertical components follow like this. X equals the magnitude, which is 18,000, times the cosine of a negative 10 degrees. Y equals the magnitude times sine of negative 10 degrees. When you calculate these, you will get the magnitude, and you can pause the video to calculate these, 17,726.5, and then negative 3125.6. Now, this is negative because we are in the 4th quadrant. Our y value should be negative. If you make a little right triangle here, your y value is in the negative direction. Here's y, here's x. Now we need to do these same exact steps, but for our red vector. That is 15,000 pounds, so it's got a force of 15,000 pounds, a positive 10 degrees from standard position. So I use the same formulas. X is going to equal, my horizontal component is x, 15,000 times the cosine of a positive 10 degrees. Y will equal 15,000 times the sine of a positive 10 degrees, which gives us the components to be 14,772.1 and 22,604.72. The more you use these formulas, the more you'll get used to them, and it'll become a little more natural. Make sure you are practicing putting this into your calculator so you know you're doing that correctly. You can pause the video, you can rewind the video. Now let's move on. That was step 1 and step 2. You had to step 1, find the horizontal and vertical components of the blue vector. Step 2, find the horizontal and vertical components of the red vector. Step 3, add component vectors together. Add the x's, add the y's. So I'm going to take this blue vector and this red vector and add their components together. 17,000, 14,000, those get added together. They're both x's. 3,125.6, or sorry, that's a negative, and a positive 2,604.72, those get added together because those are our vertical components. So when I add those together, I end up with the component form of my vector being equal to 32,498.6 and negative 520.95. That is the green vector illustrated right here. Notice it's negative. It should be negative. It's in the 4th quadrant. That y value should be negative here. That's the 3rd step. 3rd step's usually the easiest. You just have to add those components together. And then our 4th step, the 4th step is to find the magnitude and the direction of that resultant vector. So if we go back, if I go back to this picture up here, I have to find the actual length of that, and then the degree of this angle in here. So I'm going to redraw this picture with just the green vector. I have to find the magnitude and the direction of my vector. It's just below that x-axis, and it has a horizontal component of 32,498.6. Sorry, my calibration's a little bit off. And then it has a vertical component of negative 520.95. Remember, when we start working with this as a length of a triangle to calculate the magnitude and the direction, we don't need to think of this as negative. We put the negative because it's going down, but its length is not negative. You cannot have a negative length. So to calculate the magnitude of this vector that I'm going to call u, we take its Pythagorean theorem, the square root of 32,498.6 squared plus 520.95 squared, and that gives us a magnitude of 32,502.8. This is my force. This is in pounds. But if we're looking for a resultant vector, I need the force in pounds and I need the direction that it's going. So I can find my direction angle in here by using tangent of theta equals 520.95 over 32,498.6. This angle opposite over adjacent, that's how you get tangent. Use the inverse tangent. When you take the inverse tangent of this ratio, you should end up with about 0.918 degrees. Obviously my picture's not drawn to scale, but it is just going to be a little off from that x-axis. Now this is 0.918 degrees if you start going east and then go 0.918 degrees south. What we need to work on is saying our directions using one of our poles, south or north. So I want to say south, and then I've got to do 90 minus 0.918. Okay? 90 minus 0.918. Why did I choose 90? Because each quadrant is 90 degrees. You get about 89 degrees. Obviously, I'm rounding just a little bit. South, 89 degrees east. That means I'm rotating from south, from here, 89 degrees to get to that green vector. And so our two answers. Here's my magnitude. Here's my direction.